In this video, we're going to talk about decomposing a given vector into the sum of two vector components. We'll also talk about the projection of vector u onto vector v. So let's consider a boat on an inclined ramp, as we see pictured here. The force F, due to gravity, pulls the boat down the ramp and against the ramp. These two orthogonal forces, down the ramp and against the ramp, we'll call them W1 and W2, and they're the vector components of F. So it looks something like this. Here we see our component, our orthogonal vector W1, as we're going down the ramp. And here we see our vector component W2, which is going against the ramp. So here we see that the vectors W1 and W2, when we add them together, give us our vector F, our force. Now, the negative of component W1 represents the force that's needed to keep the boat from rolling back down the ramp, and in this case, back into the water. And W2 represents the force that the tires have to withstand against the ramp. So the question becomes, how can we find W1 and W2? So let's take a look at this really quick. So let's talk about our definition of vector components, because that's going to help us figure out how to find our W1 and our W2. So we're going to let u and v be non-zero vectors such that u equals W1 plus W2. So that's kind of like our capital F, where W1 and W2 are orthogonal, and W1 is parallel to, or a scalar multiple of v. And so these are our vector components we were talking about with our boat. So vector W1 is the projection of u onto v. So that's kind of easier to talk about if we look at the illustration to the right with the flashlight. And so here we have vector u. Right? It's either going to be here, or it could even be over here, right, if it was an obtuse angle. So think of the projection, kind of like a light being shined onto it, and it's like its shadow. And so W1 is going to be the projection of u onto v. Right? So there's like our W1, and so it could either be going in the same direction as v, or it could even be going in the opposite direction of v. And it's denoted by W1 equals the projection of u onto v. Now, the vector W2, right, the vector W2 is going to be given by the vector u minus our vector W1. Now, what is this projection of u onto v? Well, the projection of u onto v is an equation. So here we're going to have the dot product of u and v divided by the magnitude of vector v squared, all times vector v. Let's do an example to get a little bit better idea of how this is going to work. So in this example, we want to find the projection of u onto v. We have components for u of 3 and negative 5, and the components of v as 6 and 2. Then we're going to write u as the sum of two orthogonal vectors one of which is the projection of u onto v. Now the projection of u onto v is our W1, which remember is the dot product of u and v divided by the magnitude of v squared all times v. So let's go ahead and let's find that. So we'll begin by finding the dot product of u and v, which is 3 times 6 plus negative 5 times 2, which gives us a value of 8. Then, using our dot product properties, we know that the absolute value, not the absolute value, the magnitude of vector v quantity squared is going to be our vector v times, or the dot product with our vector v, which is going to be 6 times 6 plus 2 times 2, which gives us a value of 40. So we can now plug those values in, and that's going to give us an 8 over 40 times our vector v, which is 6, 2. And from there we'll distribute our 8 over 40, which is going to give us a 6 over 5, 2 over 5. Now our other component is going to be W2, which recall we said was going to be our vector u minus our vector W1. And so we can go ahead and plug those in. And so we have 3, negative 5 minus 6 over 5, 2 over 5. Now if we take 3 and we subtract our 6/5, we're going to get 9/5. And if we take negative 5 and we subtract 2/5, we're going to get a negative 27 over 5. And so now we have our W2. And now we have both vector components. And so we can write that our vector u, which we know is made up of W1 and W2 summed together, we can now write that as 6/5, 2/5 plus 9/5, negative 27/5. And if we work that out, we could check our answer, and we would see that this would give us that u is the components 3 and negative 5. And so here we found each of our different components here and here. And then here we've written our vector u as the sum of two orthogonal vectors, one of which was the projection of u onto v.